Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video, we'll be talking about something we are going to make use of in our calculation for rotor speed. But this video we're talking about frequency of rotor current, and it is just how often the rotor current alternates per second. Okay, so frequency of rotor current just means like this refers to how often the rotor current alternates per second. Now, when the rotor current is stationary, the frequency of rotor current is the same as supply frequency. For our supply frequency, F. Okay, that's our supply frequency. Okay, that's our supply frequency F. Now, the frequency of rotor current, we take it as this F prime, and we are saying if it's stationary, F prime equals F. So this is when the rotor current is stationary. Okay, so when the rotor is stationary, that's when this happens. Okay, the frequency of rotor current equals the supply frequency. But when the rotor starts revolving, the frequency depends, that's the frequency of the rotor current. Okay, so the frequency depends upon the relative speed, which is the slip speed. So what we are saying is this. So the frequency of the rotor current depends on the slip speed, and recall that slip speed, we said, is the difference between the synchronous speed and then the rotor speed. This is the slip speed. And there is something we made mention of the last time, saying 120 over P. But now we are talking about the frequency of rotor current. Now it depends on the synchronous speed. Okay, and the formula I'm trying to refer to is this formula, this one here. NS equals 120 F over P. That's the number of poles. So we have two formulas here. So this, you can see this one is supply frequency, while what we have here is the frequency of the rotor current. That's what we have here. So this is NS equals this, and this is slip speed equals this. So if we just kind of, these two formulas, we bring them together, say this, or let's say this divides this. So just like saying, let me do it this way, just like saying everything here, we use it to divide what we have here. Okay, to divide what we have here. So that means this comes under, and then this comes under this. Okay, so yeah, divided by this, and this divided by this. Good. But of course, we know this is the same thing as S. If you recall from the last video, this expression is the same thing as S. Okay, so we can simply write this as saying S. That's everything here. Okay, that's everything here. S equals, what we have there is 120 F prime, this, and then divided by 120 F over P. And of course, we can just switch this thing over, okay, like normal algebra now. So here will become multiplication, and then these guys will switch. Okay, those guys will switch. So we'll now have the P on top of it, and then we have the 120 and F under it. Okay, so when this happens, of course, okay, so what we're going to have left there is S equals F prime all over F, and this implies that S, we have SF, equals F prime, which means F prime equals SF. And this perfectly matches with what we said in the formula. I mean, the statement given above, saying that, but when the rotor starts revolving, the frequency, that's the frequency of rotor current, which is this F prime, depends on the relative speed, which is the slip. It depends upon the relative speed. Okay, so not just the relative speed alone, but the relative speed multiplied by the frequency, supply frequency. Remember that if our slip is unity, that is if our slip is 1, okay, if our slip is 1, it means it's stationary. So if we have slip as 1, of course, when we have 1 here, F prime equals 1 multiplied by F. That's just simply F prime equals F. Okay, so that's just like the first thing written here, F prime equals F. That is if our slip is unity, is 1. Okay, all right, so that's just it for this idea of frequency of rotor currents. We have to bear this in mind. So of course you can always come back to this video or check other videos online to have this concept in mind, because we are going to need it when calculating for our rotor speed. So I just hope this video helps in one way or the other. Okay, so what we talked about in this video is just what a rotor current is and what happens when the rotor is stationary, and how by calculation how the frequency of rotor current when it is stationary, I mean when it is revolving, how the frequency of rotor current equals the slip and then the supply frequency. We are going to need this formula later on. Okay, so of course drop comment in the comment section, and then like, share, subscribe, click on notification bell, and anything else I think I would have explained, just leave comments in the comment section. Okay, and see you in the next video. Thanks a lot for watching, and bye for now.